India occupies 2.4% of the world's land, housing more than 17% of global population, while having only 4% of global renewable water resources. This implies a significant pressure on its limited water resources. Average annual rainfall in India is 4,000 billion cubic meter, out of which 3,000 billion cubic meter, that is 75 to 80%, is received during the monsoon season of 4 months. This increases the chances of flooding during this time period. At the same time, increasing the chances of drought during the lean period. Even the monsoon rainfall is not evenly received throughout India. Places like the Western Ghat, the Himalayan foothills, and Northeast receive abundant rainfall, whereas the interior and leeward part of the country receive less rainfall, like Rajasthan, Maharashtra, Telangana. Monsoon has a profound implication on the agriculture, economy, water availability, and the environment. 51% of the agriculture in India is rain-fed, which is responsible for 40% of the food production of the country. Agriculture contributes around 17% to the total GDP and is responsible for over 50% of the total employment in the country. More than 70% of the rural population depends on agriculture for their livelihood. Water reserves and major dams and hydroelectric power generation hinge on monsoon reliability, as well as water availability for the rest of the year. Moreover, many ecosystems, including forest and wetland, are adapted to this monsoon cycle, so any deviation can disrupt biodiversity and ecosystem health. A good monsoon can lead to increased agriculture yields, boost economy, whereas a failed monsoon can lead to drought, impacting not just agriculture but also drinking water supplies. Over the years, there has been a noted variability in the monsoon, including untimely rainfall, deficient rainfall in patches, or excessive rainfall leading to floods. This has been further exacerbated by climate change. Global warming and climate change can alter monsoon patterns. There is evidence to suggest increased frequency of extreme rainfall events and decreased moderate rainfall events. At the same time, rapid urbanization, especially without proper drainage infrastructure, increases flood risk during heavy monsoon rains. Rainwater harvesting should be promoted to capture abundant monsoon rains. Advanced technology is being used to predict monsoon patterns more accurately to aid farmers and policymakers. Promoting sustainable urbanization with proper infrastructure and promoting drought resistant crops and efficient irrigation methods can help to mitigate the adverse effect of a weak monsoon. Another dimension of water resource distribution in India is that out of the total average annual rainfall, around 50% is lost either due to evaporation or is retained in the soil as soil moisture. The phenomena of evaporation and soil moisture retention has profound implications for the distribution and management of water resources in India. Evaporation is the process by which water is converted from its liquid form to its vapor form. Soil moisture retention refers to the water held in the gaps between soil particles. How much water will be evaporated or retained in the soil will depend upon many factors, mainly climate and soil type. Areas with high temperature and strong sunlight, like the Thar Desert, experience higher evaporation rates. Sandy soils retain less water compared to clay soils. The former has larger particles with bigger gaps, leading to rapid percolation. Soil moisture is crucial for crops. In regions with erratic rainfall, the retained soil moisture can be the difference between crop failure and a decent harvest. It also plays a crucial role in groundwater recharge. The retained water in the soil can percolate deeper to recharge aquifers, which is essential for maintaining groundwater levels. Soil moisture also helps in maintaining the river flow. Not all rainwater that hits the ground makes its way to rivers immediately. Some of it is retained in the soil and gradually released, ensuring rivers have some flow even in non-rainy season. High evaporation rates, especially in arid and semi-arid regions, can increase water scarcity. Urbanization and deforestation can alter soil structure, reducing the land's capability to retain moisture. Excessive evaporation in irrigation fields can leave salts behind, affecting soil quality and agriculture. Now, these are some of the remedies which we can adopt to help soil retain more soil moisture and reduce evaporation. First is rainwater harvesting. By capturing rainwater, the losses due to immediate evaporation can be reduced and the collected water can be used during drier periods. Mulching. Covering the soil with organic matter or other materials can reduce evaporation from the soil surface, preserving soil moisture. Afforestation. Trees and vegetation increase soil structure and organic content, enhancing the soil's water retention capacity. Drip irrigation. This method reduces water wastage, ensuring that the water reaches plant roots and minimizes evaporation. Constructing check dams. These structures slow down the flow of water, promoting groundwater recharge and reducing direct evaporation. As we have seen in the previous video that the average annual rainfall is 4,000 billion cubic meter, out of which 50% is distributed in the form of evaporation or soil moisture, and approximately 50% of which is infiltrated under the ground in the form of groundwater. Now the next component is surface water. Approximately 50% of the total average annual rainfall makes its way into the river, and according to NCERT data, 1869 billion cubic meter is the total surface water that flows into the river. As you know, there are more than 10,000 rivers in India. NCERT data shows us that out of this total groundwater and the surface water which is flowing in the river, this is the utilizable potential that we can effectively harness or put to beneficial use, thus representing the utilizable potential of surface and groundwater in India, which is 1122 billion cubic meter, whereas the projected demand in India by 2025 is 1500 billion cubic meter. That means there is going to be a deficit in the near future. Now let's have a look at the NCERT data and try to figure out what can be done to effectively manage our water resources. Agriculture, which is responsible for 85% of total water usage. At the same time, with increasing urbanization in industries, qualitative changes have also been taking place, mainly because of pollution from household and industries, which contribute around 80% of the total pollution. This means agriculture is causing major quantitative changes in our water resources. We are using a lot more water than we used to, primarily for irrigation and farming. On the other hand, it is our industries and household that lead to major qualitative changes. This means the quality of the water we have is declining due to pollution and waste. But not all is lost. There are solutions we can adopt to tackle this depletion and degradation. For agriculture, efficient irrigation by using drip irrigation and sprinklers, we can minimize water wastage and ensure crops get just the amount they need. By rainwater harvesting, farms can set up systems to collect and store rainwater, using it during dry periods. By growing crops that are suited to the local climate and require less water can be a game changer. In industries, wastewater treatment before releasing water back into nature, industries should treat it to remove harmful chemicals and pollutants. By recycling water, industries can reuse water within their processes, reducing the total amount of fresh water they consume. By adopting eco-friendly processes and technologies, it can minimize water use and contamination. At the household level, simple steps like fixing leaks, using water-saving appliances, and turning off taps when not in use can make a big difference, thereby reducing consumption. Avoid flushing or disposing of chemicals, oils, or medicines down drains. These can contaminate water resources. We should educate and spread awareness. The more we know, the more we can do. Sharing knowledge about water conservation with family and neighbors amplifies our collective impact. This, along with afforestation and reforestation, can go a long way in increasing the quantity as well as the quality of the water resources. In conclusion, water is a shared responsibility. Each drop counts, and every action, big or small, has a ripple effect on our water resources. By making mindful choices in agriculture, industries, and our homes, we can ensure a sustainable and healthy future for all. Various other projects have also been proposed to effectively manage the water resources in India, and we will discuss one such project in the next video, that is river interlinking. Then we will discuss the surface water and groundwater in India, and at the end we will discuss some of the water disputes in India at the national and international level. Till then, you can attempt these previous year questions for UPSC mains.